Welcome to another lesson. This is the first lesson where we start discussing the topic of dynamic arrays. It's a fundamental data structure that you will use quite often, and we will discuss also the advantages and disadvantages between dynamic arrays versus linked lists. In this lesson, we will also start the discussion of an object-oriented programming approach to the data structures. So currently we were using more of a functional way. So our functions were had this prefix list, and then it would be called, let's say, append, for example, and then you would pass the data as an integer, and then you would pass the list here, linked list, and we would return a linked list like this. So this style is also common in some programming languages. For example, in C programming, you would do it like this. But in Java and Kotlin and many other languages that support this object-oriented programming style, this is not how you would do it. So I did this on purpose so that you have a feel for how it looks like. And now with the array, with the dynamic arrays, we will switch into an object-oriented approach, and we will also then later revisit how to change our linked list functions to use also this object-oriented approach. And you will see the benefits of using an object-oriented approach with the concept of encapsulation, which is critical to understand in this object-oriented programming approach. So before we had our class linked list, that was something like this, linked list, that we had our data, var data, that was an integer, and here next, that was a linked list that can be null. This was our linked list. But the reason why this does not reflect an object-oriented style of programming is because there are no operations inside the linked list. You just define basically the structure of how a linked list looks like, but there are no operations. The operations are declared outside. In an object-oriented approach, the operations that are possible with this data structure would be defined inside this data structure. So what is a dynamic array? A dynamic array is another solution to our initial problem of loading some data to memory without knowing in advance how many items we need to read. So I presented you with linked lists as a solution to that problem, but they have some disadvantages, because if we want to do a binary search, we are not able to do it on a linked list. But with an array, for example, if we have an array like this, 0, 1, 2, 3, 4, 5, 6, we can immediately access A3, which would be, of course, the length of the array divided by 2. We can immediately access this and know if we need to continue searching left or right. And the way that we solve this problem with the dynamic arrays is that if we find that there is no space left, so all of these positions are have elements, and we want to add another element, we will create a new array that is bigger than this one by a certain percentage, and we copy everything to the new array, and then we discard this one. So this is basically what a dynamic array is. So depending on the programming language, the growth percentage will be different. In the case of Java, it grows by 50%. And in the case of C++ and C#, it grows by 100%. So it doubles in size. So for example, let's use this as an example. I will delete this one for the sake of space. So if we have an array like this, with 3 elements, for example, like here it's 3, 4, 1, and we want to add another number, and there's no space for that number, we grow this, let's say we double the size, and so we allocate another array with double the size, and we copy everything that we have here. So this number goes here, this number goes here, this number goes here, and now we have space for the new one, and we still have 2 slots free. And we keep doing this until we read all the data. We keep doubling and doubling and doubling the size of the array, or increasing by 50% in the case of Java. So different languages have different algorithms. Python has its own particularities, JavaScript as well. But in the end, the basic concept of a dynamic array is that it will, once it's full, it will create a new one. It will allocate memory for a new array with a certain percentage added and copies everything to the new array and discards the old array. So this is the basics that you need to understand about dynamic arrays, and we will implement this in using an object-oriented programming style so that you can contrast this approach with the linked list approach that we have here, where we have the structure here, the class, just with the definition of what the linked list is, and then the operations are outside. And here we will look into how we can So if we have an array like this, let's say 3, 1, 4, and we want to add, let's say, number 6, what we would do, because there's no capacity, we allocate a new array with double the size. We copy everything. So here will be, this goes here. All the indices are copied exactly the same. And then we have space for our 6, and we still have here 2 spaces left. So independently of the growth, because different languages have, on the standard library, each language has its own growth percentage. Independently of the growth percentage, what you need to understand is that the dynamic array is just this. So you have some array allocated, and if there's no space, you allocate a new one with a certain percentage added, and you copy everything to the new array, and then you have space for the new one. So basically that's it. So let's see how this would look like using an object-oriented programming approach, and then you can contrast with what we have with the linked list. And then, of course, we will change the linked list implementation to also use the object-oriented approach, and you will see the power and the benefits of approaching it like this. So what we will have is here a class dynamic array. So here we would have, of course, the operations append that gets some data as an integer. And here a function, let's say, contains with some data, integer that returns a Boolean. And you probably see the contrast already. Before we had list append that gets some data and a list, and here, and would return also a list, right? And here, the function append does not have the list parameter and also does not return a new list. So this is the biggest contrast that you need to understand when you are on an object-oriented programming style, is that you are requesting the dynamic array to change itself. So when you pass it a piece of data, it will add it to itself. So I will erase this part of the board so that you see the difference between both approaches. So here, when we had the linked list variation, we have a certain var list equals null. And of course, we need to specify the type. Linked list equals null. And now if we want to add an element, we do list equals list append with number 5, for example, to our list. right? So you have this style where you say list equals, then function name, and then you do this. With the dynamic array, it will be very different because we will have our value. Let's call it like this, or we can even call it a list. List equals dynamic array, like this. We are creating an object of the class dynamic array. So creating objects is something that you have seen many times. And now, instead of doing list equals, we do list dot append 5. And we can do if, for example, if list dot contains 5, like these kind of things. So it's a completely different style of programming, and this, you have seen this already many times because we were working with files, also with the classes provided by the standard library. When we are reading from the files, you would do file.read, for example, and this is the approach that we will take to implement the dynamic arrays, and you will see the difference compared to the linked lists. So let's learn how to implement a dynamic array. So see you in the next one.